Hello, good morning all. Welcome to my channel Vijay's Physics Sprint. So today we are going to discuss about electric field, electric field intensity, and last two classes is based on Coulomb inverse square law and electric lines of force. So please follow those two videos and continuation, and this is the third class, electric field and electric field intensity. Electric field. So field, it is nothing but the region. So the region of the charge. Last class we discussed about electric lines of force. Electric line of force is nothing but the imaginary path of unit positive charge. So if it is a positive charge, electric lines of force are outwards, right? So if you place a negative charge which is far away from the positive, lot of distance, long distance it is there. So in between those two charges, no attraction, no repulsion, because distance it is more. So we know that the force of attraction and repulsion inversely proportional to square of distance. So distance is more, the force is going to be negligible. Now bring this negative charge closer to the positive, then what happens? So it takes attraction. Nothing but this charge attracts or repels one more charge at certain region only, and that region it is called as electric field. Electric field is nothing but the region of the charge where it experiences the attraction or repulsion force, that is called as electric field. It's like a space, right? It's a three-dimensional space. It is a own property of the charge. So where you experience the attraction or repulsion force, the region it is called as electric field. In this electric field only electric lines of force are exist. So if you place one more charge in the electric field, it experiences attraction or repulsion. If it is unlike charges, attraction force. If it is like charges, repulsion force. So the region it is called as electric field. Now we are placing this charge in the electric field. How much of force acting on the charge per unit charge, it is called as electric field intensity. Electric field intensity means electric field intensity. The force acting per unit positive charge, it is called as electric field intensity, E equal to F by Q. F is a force and Q is a charge. If you write the unit of this electric field intensity, force is nothing but Newton and charge is nothing but Coulomb. So Newton per Coulomb or volt per meter. So volt per meter, it is the relation between electric field intensity to potential. From that we get this unit, volt per meter. So E equal to F by Q is a vector. So E bar is equals to F by Q. What is the direction of this electric field intensity? For example, it's a positive charge and this is negative charge. Right? In between these forces, due to plus Q, the force on minus Q is F is equals to plus EQ. Force F is equals to EQ. Okay? Due to minus Q, the force on plus Q it is F is equals to minus EQ. This is the force direction. Due to plus Q, on minus Q is plus EQ, and due to minus Q, on plus Q it is minus EQ. But electric field intensity always from high charge to low charge or positive to negative charge. So electric field intensity in this direction, E bar. Here also electric field intensity in this direction. So electric field intensity always from high to low charge or positive to negative charge, but the force is going to be different. Equal magnitude only. If you can take the magnitude, it is same, but the directions are different. But electric field intensity is direction, it is same, right? So electric field intensity E equal to F by Q. Unit is Newton per Coulomb or volt per meter, and directions you have to remember. And electric field as Neet, electric dipole. Dipole, di is nothing but two equal and opposite charges separated a minimum distance, the arrangement it is called as electric dipole. Two equal magnitude but opposite charges, one it is positive and other it is negative. So two equal and opposite charges separated a certain distance, that is known as electric dipole. So in the electric dipole, right, this is the electric lines of force, positive to negative, right. Last class also we discussed about these electric lines of force. Okay, this is the electric lines of force. For electric dipole, the distance between these positive and negative charges, it is indicated with the 2a. From center to positive charge it is a, and center to one more charge it is a. So total distance which is equals to 2a. It is analogous to magnetic dipole or simply bar magnet. Bar magnet has two equal poles north and south and separated by 2l distance. Same here also is an electric dipole, equal and opposite charges, separated distance of 2a, and that is called as electric dipole. The charge and the distance, the product of charge and distance, it is called as electric dipole moment. Electric dipole moment. Electric dipole moment vector. So P equal to 2eq. So product of the charge and distance between the charges, it is called as electric dipole moment vector. And what is the unit of this electric dipole moment vector? Distance is nothing but meter and charge is nothing but coulomb. So the unit it is coulomb. Meter is a unit of electric dipole moment vector. Okay. Now we'll discuss about what is electric field intensity due to electric dipole. So before calculating electric field intensity due to dipole, what is the electric field intensity to a single charge or the point charge? So due to point charge, what is electric field intensity? Calculation of electric field intensity due to point charge, and then after we'll discuss about electric field intensity due to electric dipole. Okay, so due to point charge, just imagine a charge Q. Q is a charge and this is the electric field intensity around the charge. If you can place one more charge in this electric field, then only in between those two charges attraction or repulsion force will act. Now one more charge, a test charge, positive test charge, which is outside the electric field. Outside means no attraction and no repulsion. Now carry this into the electric field. Okay, let us say you kept this Q naught from A to B at the distance of R, right? Q naught charge. Now it is in the electric field, so it experiences some electrostatic force. What is electrostatic force? F is equals to K Q naught by R square. K is 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. Now Q naught, bring this side, F by Q naught equal to K Q by R square. Force acting per unit positive charge. Force acting per unit positive charge is nothing but electric field intensity. So F by Q naught is replaced with E equal to K Q by R square. So this is the electric field intensity due to point charge. Due to point charge, electric field intensity equal to K Q by R square. K is nothing but already we know is a 1 by 4 pi epsilon naught Q by R square. So this is the electric field intensity due to point charge for the single charge. Right? Now, what is electric field intensity due to electric dipole? So now we'll discuss about electric field intensity due to electric dipole. So electric dipole means two equal and opposite charges separated by minimum distance. It is called as electric dipole. So the midpoint it is O, the distance which is equals to 2a. Okay. Now consider a point P at the distance of r from the center, and due to plus q charge and due to minus q charge. Okay. So at point P, the electric field intensity is E bar, which we have to calculate. What is the value of E bar? I am writing polar coordinates, nothing but radial as well as transverse component. So this is a radial component ER and transverse component which is equals to E theta. Radial as well as transverse component. So ER is a radial component of electric field intensity, nothing but minus dou V by dou R. Is a partial differentiation of potential, the negative gradient. So what is the potential at point P? Potential at point P. So V is equals to P cos theta by 4 pi epsilon naught R square. What is P? Electric dipole moment vector. Just now we wrote P equal to 2aq, electric dipole moment vector. So calculating ER, that is ER equal to minus dou by dou R of potential P cos theta by 4 pi epsilon naught R square. So ER P cos theta 4 pi epsilon naught is constant. Dou by dou R of 1 by R square, nothing but minus, here already minus it is there. So minus 2 by R cube, minus of minus plus. So the radial component becomes minus of minus plus. So 2p cos theta by 4 pi epsilon naught R cube. This is radial component of electric field. Now transverse component. Transverse component, that nothing but E theta equal to minus 1 by R dou V by dou theta. This is the transverse component. Then E theta equal to minus 1 by R dou by dou theta of potential, that is P cos theta by 4 pi epsilon naught R square, that is E theta equal to dou by dou theta of cos theta minus sin theta, minus of minus plus. So P sin theta by 4 pi epsilon naught R into R square, nothing but R cube. This is transverse component. So radial component as well as transverse component. So therefore the resultant electric field E bar at point P can be written as point P. The resultant electric field intensity at point P equal to root over ER square plus E theta square, that is E equal to ER, that is 4P square cos square theta 4 pi epsilon naught R cube whole square, applying the square, plus E theta square, that is P square sin square theta by 4 pi epsilon naught R cube whole square. So taken outside the root, that is 1 by 4 pi epsilon naught R cube. P square is taken out. Okay. 4 cos square theta plus sin square theta. P also you can take out of the root, that is P by 4 pi epsilon naught R cube 4 cos square theta sin square theta written as 1 minus cos square theta. Sin square theta plus cos square theta value 1. So 1 minus cos square. 4 cos square minus cos square. So the resultant electric field becomes P by 4 pi epsilon naught R cube 1 plus 3 cos square theta. So this is the general expression for electric field intensity at any point due to the electric dipole E equal to P by 4 pi epsilon naught R cube root over 1 plus 3 cos square theta. P already we know, electric dipole moment vector. Now see some special cases. What is the value of theta? If theta equal to 0, case 1. If theta is 0, theta equal to 0 means the point it is along the axis, and this axis is known as axial line. What do you mean by the axial line? The line passing through the charges and midpoint, it is called as axial line. On the axial line, theta equal to 0. Now substitute cos 0, it is 1. 1 plus 3, 4. Root over 4 is nothing but 2. So electric field intensity becomes 2p by 4 pi epsilon naught R cube. Okay. This is the electric field intensity on the point, at the point along the axial line. Now case 2. Case 2. If theta is equals to 90 degrees, theta equals to 90 degrees, what happens? Now 90 degrees means this is electric dipole, the axial line. Now point P. And this line is known as equatorial line. Equatorial line. What do you mean by the equatorial line? The line passing through midpoint perpendicular to axial line. The line passing through midpoint of the dipole and perpendicular to axial line, that is called as equatorial line. So for equatorial line, theta is equals to 90, cos 90, 0. So the electric field intensity P by 4 pi epsilon naught R cube. This is along equatorial and this is along axial line. Okay. So P you can represent as 2aq. Right. So 2aq by 4 pi epsilon naught R cube. And here also P you can replace with 2aq. So this is the axial line, electric field intensity at a point on axial line, and it is at the equatorial line, and it is a general expression. So this is the resultant magnitude on axial as well as equatorial, and this is general expression. And what is the direction of this electric field? So direction, I am calculating direction of the resultant electric field. Right. Just now we draw this graph. Right. This is point P. Okay. And this is electric field intensity E bar. And this is the radial electric field, and this is transverse electric field. So the resultant direction I am calculating phi. Okay. So tan phi is nothing but transverse component by radial component. That is tan phi equal to E theta. Just now we derive E theta, that is P sin theta by 4 pi epsilon naught R cube. Radial component 2p cos theta by 4 pi epsilon naught R cube. Already we derived these two equations for radial as well as transverse electric field. So cancelled out, then tan phi equal to P cancel, right? 4 pi epsilon naught R cube cancel, sin by cos, nothing but tan theta by 2. So we need the resultant direction of the electric field intensity, phi equal to tan inverse of tan theta. This is the direction of resultant electric field intensity. So this is the magnitude and this is the resultant direction. You can place theta value 0 for axial line. Here also theta is equals to 90 for equatorial line. You will get the magnitude and direction of the electric field intensity. Okay. So if you have any doubts, so type the question in comment box. So like, share, subscribe my channel, support my channel. Have a great day.